All right, so new unit today. All right, so here we go. All right. So the good news is this should be a little bit familiar to you from Algebra 1. Okay, rational functions, what we just went through, was a little bit newer, right? Not quite as familiar to us. Okay, so exponential functions. Exponential functions. Okay. Okay. So an exponential function have the form we'll just jump right into this, I guess. Y equals A times B to the X minus H plus K. So again, we can see all of our transformations right in there, right? We can see all of our transformations in there, okay? So we call it, it's an exponential function, right? It's exponential because our x is in the exponent, right? Our variable x is in the exponent. All these other numbers, a, b, h, and k, they're going to be like filled in, right? We're going to have values for those things. But the x, right, the exponent has the x in it, the variable, okay? There isn't a single parent function here, right? There's no single parent function because this b value changes, right? It can be any sort of number we need it to be or want it to be kind of thing. And so there is no like single parent function, but there still is kind of like a general shape to the graph and stuff like that. All right. I will say here a couple stipulations though. B is going to be between 0 and 1, or b will be greater than 1. Okay. So b is going to be between 0 and 1, or b will be greater than 1 here. Okay. We don't want to talk about a negative b because then we could potentially be taking the square, like we could have b to like the negative 1/2 or something like that, and negative 1/2. You could be taking a negative number to like a square root or something like that, and so we don't have to worry about that. So we won't be having negative b values. Okay. We also won't have b be 0 because if b is 0, well, you'll have 0 to the x, and what is 0 to the x going to be always? 0, right? And so you're just going to have 0 times a, it'll be 0 plus k, and so it's just y equals k. That's not going to be exponential, that'll just be a horizontal line through k, okay? Likewise, also, b is not going to be equal to 1 because if b is 1, if you put a 1 in for b, well, what's 1 to the x always going to be? 1, and you'll have 1 times a, which will just be a plus k, and so then you'll have another horizontal line, a plus k there. So b will never be 0 or 1. It won't be exponential if you have b being 0 or 1, something like that. Okay? All right. So there's our graph. And so let's talk about some of these aspects here. So again, A is going to be a stretch or a shrink. So a is greater than 1. We'll have a stretch. 0 less than a, less than 1. So a between 0 and 1, that'll be a shrink. Or I should say stretch by a, and then shrink by a. Okay. Okay. So that's your a value there. Okay, and of course if a is negative, so if a is less than 0, what does a negative a value normally do to our graph? If you have a negative number out front here, what does that negative do? Reflection over x, yeah. Very good. Okay. I'm going to real quick also talk about B. The B value there is known as the growth or decay factor. Okay. The growth or decay factor, that's B. Okay. If B is greater than 1, what do you guys think? If B is greater than 1, is that going to be a growth or a decay? Growth, right? Because we're going to repeatedly multiply by a number that's bigger than 1, so it's going to get bigger and bigger and bigger and bigger and bigger, right? So that's the growth one. Okay? And so then decay, that's going to be for B values between 0 and 1. Okay? Decay between 0 and 1, right? If you keep multiplying by 1/2, right? 1/2 is between 0 and 1, for example. If you keep multiplying by 1/2 over and over and over again, you're going to get smaller and smaller values, right? Right? And of course then H, what's that H going to be responsible for? Okay, it's going to be shifting things, right? Shifting things which direction? Left or right, okay, yeah. So if you have X minus H, then that means we're going to shift to the right H units, right? And if we have X plus H, what does that mean? We're going to shift left H units. Okay? And then K. Okay? And if we have a plus K, that means you're going to be shifting which direction here? If we, well, careful, it's on the outside, so now we're going up or down, right? So this is going to go up K units, right? Up K units. Okay? And if we have a minus K, that means we're going to go down K units. Now today we're going to focus strictly on growth functions. Okay, today we're going to focus strictly on growth functions. Okay. So there's that. Again, nothing new, right? That's stuff we've seen already. The only additional piece here is this B part, right? Where B is going to be our growth or decay factor. We haven't had that B show up with transformations, at least, kind of thing. So, questions on anything so far? Same stuff we've been looking at, but just any questions? Anything unclear? All right. So then, let's graph some of these functions here. So let's consider f of x equal to 2 to the x. Okay. So let's first of all, let's make a table of values for it here. I'll make a horizontal table. So I'll make some x values, and then we'll pick some function values as well. And for the x values, I'll start with some negative numbers, actually. Okay, I'll go from -3 to 3. Just pick some nice values there. Is this graph going to be shifted left or right at all? Is this graph shifted left or right? Does it have a left or right transformation with it? Nope. Does it have a shift up or down at all? Nope. Does it have a stretch or a shrink with it? No. No. Okay, that 2, remember, that 2 is being raised to the x, right? And so it's 2 is the b value here, okay? Since the b value is 2, do we expect a growth or a decay here? It's going to be growth, right? Because 2 is greater than 1, so it's going to be, we expect a growth. Okay, so let's see what happens here. Okay, let's hold off on evaluating these negative numbers first, and let's do the positive ones, or at least 0 first. So let's plug in 0. 2 to the 0 power, what's that going to be?
0.
Not 0.
Oh, 2.
Nope, not 2 either. What's 2 to the 0 power? Maybe we should do an easier one. What's 2 to the 1? 2 to the first power is 2. Yeah, it's just going to be 2. Okay. How about 2 to the second power? 4, right? Okay. 2 to the third power? 8, right? 2 to the third, 2 to the third. So 2 times 2 times 2, 8. Okay? So, all right, 2, 4, 8. So now let's go back one more here, x value to 0. So at 3 it was 8, at 2 it was 4, at 1 it was 2. What should we do here to get then what 2 to the 0 is going to be? What are we doing every time here? 8 to 4 to 2, what's that? What are we doing? Yeah, we're dividing by 2 every time, right? So what should this value be right here? A 1. 2 divided by 2 is 1. Okay? And we can continue using that pattern, right? So again, divide by 2, I get 4. Divide by 2, I get 2. Divide by 2, I get 1. If I continue that pattern, if I divide 1 by 2, what does that mean this value is going to be? Yeah, 0.5, or I'm going to leave it as 1/2. Mm-hmm. And then what's half of 1/2? 1/4. And then what's half of 1/4? 1/8. Okay, we're multiplying by 1/2 every time. Okay, well, you can also think of multiplying by 1/2 instead of dividing by 2. If you don't believe me, here, you can type this in your calculator, right? Like 2 to the negative 1/3, or 2 to the negative third, I mean. Okay, so 2 to the negative 3. Oops, I forgot to put parentheses around that. 0.125, math enter, enter. 1/8 is what you get there. I'm going to change my stuff back to pretty print. Okay, so we do get our answer there of 1/8, right? Okay. Now, 2 to the positive 3 gives us 8. 2 to the negative 3 gives us 1/8, right? 2 to the positive 2 gives us 4. 2 to the negative 2 gives us 1/4. 2 to the 1 gives us 2. 2 to the negative 1 gives us 1/2. You see the pattern there? So evaluating 2 to the negative 3 is just like evaluating 2 to the third, but it's just the reciprocal. It's just the reciprocal. Okay? So, something to keep in mind there too. All right, now let's graph this. Let's graph this thing. Okay, let's graph this thing. So, you can see here that all my y values are positive, so I'm going to focus on the positive part of the y-axis here and kind of ignore the negative part. One, 2, 3, 4, 5, 6, 7, 8. Okay, so these are all going to be counting by ones. And I'll plot these with red. All right, so let's plot the points here. I'll hold off on the fractions for right now. Let's just do 0, 1. That's an easy enough one. 0, 1. So there's our first point there. Okay. And then 1, 2. And sorry, maybe I should slow down here. So 0, 1. 1, 2. 2 then is going to give us 4, 2, 4, so 2, 4, okay, and then 3, 8. Okay, and then negative 1/2, and this is where it gets a little tricky because you're kind of just making like lower and lower numbers there. Okay, so there's our curve. There's our curve. So I will connect the dots here. Okay, I'll connect the dots here. So, any questions so far on this? That's our exponential. And you can, so do you see the growth? Do you see it? Yeah, it's increasing, right? Okay, very good. All right, so let's answer some questions about this. What's the domain of this graph? What about our x values? What does it look like the farthest left we're going to go? Infinity. Negative infinity, yeah. And what's the farthest right we're going to go? Infinity as well. Okay? You might look at this and say, Mr. Witt, is there like a vertical asymptote at some point? No. We can keep putting in any x value we want to. We can keep going. The problem is the more x values, the further you go on the x-axis here, this curve is going to go up faster and faster and faster, right? Because it's 8, and then the next one will be, 16, and then 32, and then 64. And it just keeps, it's increasingly increasing, so it's just going to like really steeply climb, okay? But you can put in any x value here. Now, how about the range? Is the range also negative infinity to infinity? Or does it look like we're going to have a like bottommost point or a highest point here? Yeah, we have a lowest value. What's the lowest value? It looks like our graph's going to approach here. What y value? What's the lowest y value it looks like we're approaching? 0. Yeah. Will we ever get to 0? No. It's impossible to take the number 2. It's impossible to take the number 2, raise it to a power, and get 0. Right? You're going to get very close, but you'll never get to actual 0. So we're going to say 0 is the lowest value, but we're going to put an open parenthesis there because it doesn't actually get there. How about the upper y values though? What's the highest y value we're going to get to? Infinity. Okay. Infinity. So, I said we didn't have a vertical asymptote here, right? There's no way that this will be undefined, right? We can't divide by 0, right? This function here will never be undefined. We won't ever divide by 0. But we do have another kind of asymptote here. Not a slant. Horizontal. Horizontal. Horizontal asymptote where? At what y value? Where does it look like we might have a horizontal asymptote that we're approaching? At what y value? 0, yeah. We're approaching 0 right here, right? So we have a horizontal asymptote right here. Now, granted, both sides don't approach it, but for a horizontal asymptote, both sides don't have to. Just the one side is, and that's good enough. So we have a horizontal asymptote at y equals 0 there, okay? How would you describe the behavior of this function? Is it increasing, decreasing, constant? How would we describe the behavior of this function? How would you describe the behavior? Is it increasing, decreasing, constant, both? None of those? What do we say here? Okay, so you're saying both. So you're saying it's both increasing and decreasing? Okay, so where do you see it increasing? When it goes up to infinity, yeah. So it's going up from left to right, right? Okay, so that's right. As you look from left to right here, we're going up. Where is it decreasing? As we go from left to right. Well, but remember, decreasing, you have to go from left to right. If you're going this direction, you're going right to left. Is there any place where it's decreasing as we go from left to right? No. This function is everywhere increasing. Everywhere it increases. Even down here, right, 1/8 to 1/4, well, 1/4 is bigger, right? And then to 1/2, well, now that's bigger. And then 1, that's bigger. 2, 4, 8, those are bigger, right? We get bigger as we go here, and that's going to be true in general. Okay, so this is increasing. From negative infinity to infinity. Okay. And remember, what kind of exponential function is this? Growth or decay? It's growth, right? So shouldn't we expect that if we're going to call this thing a growth function that we would be increasing everywhere, right? Growth and increasing. Same, they're kind of the same idea there. Okay? All right, one other thing here that I want to identify real quick. What is the y-intercept? Yes, it's at 1. 0, 1 specifically. Okay? What about the x-intercept? Trick question. There isn't one. That's right. Very good. Okay? Trick question. Because we have a horizontal asymptote, right? This will never cross the x-axis. This graph will never cross the x-axis because 2 to the x will never be 0, right? You can't raise 2 to a power and get 0. Now later we will have graphs that have x-intercepts if they shift up or down some, right? If I were to take this graph and shift it down 1, well now I would cross the x-axis, right? But with the way it's currently graphed, we can't. Okay? This point right here, the y-intercept, that's going to be like our crucial point to find. Okay? The y-intercept will be the crucial point that we want to transform. right? Just like when we had like quadratics, we transformed the vertex first, and then we got the rest of the graph. When we have the absolute value functions, right, we transformed the point of the v first, then we got the other parts of the graph, right? When we talk about rational functions, just last unit, where the vertical and horizontal asymptotes crossed, we transformed that first, and then we would, get the rest of the graph. This is what we will transform. This is like our, starting point for our graph, and then we'll pick some x values to the left and x values to the right, and graph the rest from there. Okay? So yeah, go ahead. Okay. All right. So let me just show you here real briefly some comparisons too. Now, if I take 2 to the x in my graphing calculator here, I don't want to have you guys keep graphing by hand all this time, right? So I'll do some of the graphing calculator. Okay? 2 to the x versus 10 to the x. Okay? 2 to the x versus 10 to the x. All right, let's take a look at the graph here. And let me actually do this. I'll make 10 to the x a thicker line. Okay, and I'll actually adjust it here. Let's see, I'll make my y min like -1 instead. There we go. Okay. So we'll do 2 to the x. There's 2 to the x. And there's 10 to the x. Okay? So 2 to the x and 10 to the x there. All right? What's the domain? How do the domains compare? Is 10 to the x still going to be -infinity to infinity here? You can see in the thicker one there. Will the domain still be -infinity to infinity? Yeah, it will be. Is the range still 0 to infinity for 10 to the x? Again, that thicker line. It's kind of hard to see. I mean, well, it's graphing it below the y value of 0 there, below the x-axis, but it's just because I did the thick line there. If I were to make it not thick, it would not be. So it's also got the same range, 0 to infinity there. Okay, it still is going to have a horizontal asymptote at 0. 10 to the x is still increasing as well from -infinity to infinity, and it still has the y-intercept. If you look right there, okay, go to my table, okay, they both have a y-intercept at 1, right? My y1 has an intercept at 1, and my y2 also has an intercept at 1, okay? What's different about these two graphs? So they have the same domain, the same range, same y-intercept. They're both increasing on -infinity to infinity. What's different about these two graphs, though? How can you describe the difference? TJ? Oh, bathroom? Yeah, go ahead. Oh, wait, what did you need? Sorry? Yeah, and that's because I graphed it thick. If I don't graph with a thick line, it's just because of the way the calculator's graphed. Let me change it back to a normal line here, and you'll see it better. It actually is. It also does stay above the x-axis the whole time. Sorry, no, that's the graphing calculator. It's just the way it's graphed and stuff. I was trying to differentiate the two. Okay, so there's 10 to the x right there. That's that one. So what else? What's different though? That's 10 to the x. What I was pointing at. There's 10 to the x. That's 2 to the x. 10 to the x, 2 to the x. They're both exponential growth. Can we say anything that's different, though, about how they're growing? One's going more to the right, okay? So which one's growing faster, would you say? 2 to the x or 10 to the x? So 2 to the x is the one to the right. 10 to the x is the one that's like to the left there. 10 to the x is growing faster, right? It's at earlier x values, right? It's got the same height as these over here. If you look at the table, you can see it, of course, very clearly, right? Like at x equals 4, 2 to the x is only 16, 10 to the x is 10,000, okay? So, just some other things to keep in mind, right? Shape of the graph is similar, but of course, the greater your b value is, the more you'll be growing. Okay? All right. So let's take a look then at some transformations and things, okay? We'll do a transformation here. All right, and I'll just go ahead and just jump right into like some fun ones. All right, so we'll just do that. All right, so let's sketch a graph of g of x equals -3 times 2 to the x minus 2 plus 1. Okay? Okay, so let's identify our transformations here. What kind of transformations do we see here? Okay, reflection over the x-axis with the negative 3. Reflect over x-axis. Yeah, and a vertical stretch. What clues us into the vertical stretch here? The 3, right? Okay, 3 is it's more than 1, right? That number 3 is more than 1. So reflect over the x-axis. Vertical stretch 3. Okay. What about that x minus 2? What's that minus 2 going to do? Right 2. Okay. And what about that plus 1 at the end? Up 1. Okay. So let's graph this thing here. Oops. Let me do this here. Okay, so we'll make some right 2 of 1. Oy. Okay. Very good. So let's see here. How can I do this? So we'll go over here. See if I fit it in there. I want to make sure I fit it in. Okay, here we go. Bless you. Okay. So something like this, I guess I can put another tick mark right in there. Okay. So the first thing we're going to do is we're going to come up with our we're gonna try and identify our table here. So I've got our our graph ready to go there, but I also want to come up with a table. I'm going to put the table over here next to my graph, and I'll just make like a little x, y. I'll do a vertical chart this time because that way it'll fit. Or I'll do x comma g of x, I guess we'll say. Okay. Now up here, right, I put the x value of 0 in the center, and that's because that point 0, 1, right, that's our y-intercept there, and we want to, that's kind of like our center point that we want to use to graph this function, okay? So we're going to use that same coordinate here. We're going to start with 0. I'm going to put 0 in the middle, okay? And then, but 0 though, our graph was shifted, wasn't it? Right? Our x coordinates here of 0, how are things shifted? How are our x values all shifted? Everything is shifted to the right 2. So instead of 0 being in the center, what number should now be in the center? 2. So I don't want to put 0 in the center. I'm actually going to put 2 in the center there. Okay? So sorry, we're actually going to put 2 in the center there. Okay? And then what I'll do is I'll just go a couple x values back from 2. So I'll say like 1 and then 0. Okay? And I'll also go a couple x values ahead of 2. So like 3 and then 4. Okay? So 0 is no longer our center because it got shifted to the right 2. So 2 is going to be the center point there. Okay? And then all we'll do is just we'll plug these points in to our function here. Okay? Actually, I'll keep my calculator, my thing up here. So let's plug this in. So 2. Plug in 2 for x. What's 2 minus 2? 0. What's 2 to the 0 going to be? 1. 1 times negative 3. Negative 3 plus 1. Negative 2. So there's our matching y coordinate. 2, negative 2. Okay? And let's go ahead and plot that here just so we can see the transformation. So 2, negative 2. This is that point. Okay? Now it might be a little bit weird here. We'll come back. So let's think about this, right? So our normal center point here, our normal starting point is at 0, 1. Okay, but we got to shift it right 2 and up 1. So if I count right 2, 1, 2, and then go up 1, there's where my new starting point should be. But don't forget, we also have to reflect it over the x-axis. So again, my normal starting point here is at 0, 1, right? But I have to shift it right 2, so count 1, 2 to the right, and then up 1, up 1. Okay, so there's my point, but I also have to reflect it over the x-axis. So when I reflect over the x-axis, I end up at this point right there. Okay, but of course you can use your table to help you with that as well. All right, let's plug in some of these more ones. Let's plug in some more points here. Let's plug in 3. 3 minus 2. 3 minus 2 is 1. 2 to the 1. 2 to the first power. 2 times negative 3. What's 2 times negative 3? Negative 6 plus 1. Negative 5. Okay, so now we have the point 3, negative 5. So 1, 2, 3. 1, 2, 3, 4, 5. Question? Okay, just like that. Let's see if we can fit 4 in there. 4 minus 2 is 2. 2 to the 2 is 4. So this will be 4 times negative 3 is negative 12. Plus 1 will be negative 11. That's not going to fit. I don't leave enough tick marks for that. All right, let's go backwards. I'll plug in 1. 1 minus 2, negative 1. 2 to the negative 1. Guys, remember what's 2 to the negative 1 power? It's 1 over 2 to the 1, or just 1 half. So it's 1 half times negative 3. It'll be negative 3 halves. Negative 3 halves plus 1 will be negative 1 half. Okay? So we get negative 1 half there. So 1, negative a half would be like right there. Okay? And then at 0, 0 minus 2 is negative 2. 2 to the negative 2 is 1/4, 1 over 2 squared. And negative 3 times 1/4, negative 3/4 plus 1 will be 1/4. So we get 0, 1/4. Like right there. Okay. What was the normal horizontal asymptote for our original graph of 2 to the x here? Where was the normal horizontal asymptote? At what y value? At 0. But this one, it was shifted up 1, right? If we shift it right 2, that doesn't affect the horizontal asymptote. But if we shift up 1, our new horizontal asymptote is at 1. So we can also graph in the horizontal asymptote here at 1. It got shifted up. So there's our horizontal asymptote right there. Okay, like that. So what's our graph going to do? Well, if I connect the dots here, it'll look something like this. Right? And then this one will be going down. And so there's our graph. Okay. You can also use the graphing calculators to help you with this too. Okay, you can also use your graphing calculators to help you with this too. Bless you. So the way you do that, I can just show you here. We can go to the y equals. Okay, oops, I had it typed in, didn't I? I did. Okay, negative 3. Oh, you can't see. There we go. Negative 3, 2 to the x minus 1 plus 1. Or x minus 2, sorry, x minus 2 plus 1. Go to your table. Okay, and then there are some values you can get, right? You see at 0, you get 0.25. At 1, you get negative 0.5. At 2, you get negative 2. 3, negative 5. 4, negative 11, right? That's that whole table we just did right there. Okay, so that can help you too. Use your graphing calculators to help with that. Okay, but there's our graph. Okay, so it was going to be a growth, but then a reflector of the x-axis, and it created this shape. Okay, a reflection over the x-axis creates that shape. Okay. Questions on any of that? All good? All right. So let me see here. All right, yeah, one last thing I want to talk about, and then I'll get you guys started here real quick on the homework. One little thing. Okay, I want to briefly talk okay, about the b. So okay, I'm going to briefly talk about b, that growth factor. Okay. Okay, and this is something again from Algebra 1. Since if b is a growth factor, okay, if b is greater than 1, okay, so we call b the growth factor if b is greater than 1, okay. If it's a growth factor, then b is equal to 1 plus r, where r is known as the growth rate. Okay, do you guys remember this at all from Algebra 1? Talk about 1 plus b equals 1 plus r for a growth factor. All right, well. So, the growth rate is typically a percent increase written as a decimal. Okay, a percent increase written as a decimal. Okay. So, for example, a guitar increases in value by, I don't know, let's say 9% each year. Okay, just kind of change things up here a little bit with the guitar increases value by 9% each year. Okay. So our percent, 9%, that's an it's an increase, right? A percent increase there. Okay. What is the decimal? What's 9% written as a decimal? What is it? 0.09. Careful. 0.9, what's that? What's that percent? 90%, right? So be careful here. Yeah. 0.9 equals 90%. We'll have 0.09. That's equal to 9%. Okay? So that's our R. Okay? The B then, the B value here would be 1 plus 0.09, which is equal to then 1.09. Okay? So the growth rate it grows 9% every year. The growth factor, what goes into the actual equation there, is 1.09. Okay? 1.09. Okay? So that B value, that determines the growth of your the growth of the value of object, or the decrease of value. We'll talk about like losing value tomorrow with decay. Okay. One other thing here, A, that is like the initial or starting amount. Okay. Slash value. Okay. So A is like the initial or starting amount or value. Okay, you want to say there. So A would be like your initial or starting amount. So if the guitar was originally worth $100, you put 100 in for A, stuff like that. Okay. All right. So, questions on any of that? All right. So, rest of the time then, I'll give you guys here to work on this stuff. That seemed like took a while there, but anyway, all right. So, your assignment's going to be on page 470. Numbers 1 through 8, okay? Identify the transformation only, please. Okay, and then 11 and 12, find domain slash range. Actually, I should do it this way. Graph it and then find domain range. also like you to try 18 and 20 as well. Okay. So yeah, so use those 10 minutes here. Let's get started on these. Okay, again, number 1 through 8, you're just identifying transformations. 11 and 12, you're actually graphing. And then 18 and 20, you got some other problems there for you to work on. Okay. There's a few books I know in the back row there in people's desks, so we can use those, or of course you want to get it out. That'll be in section 13-1, I think, by the way. I think we're in 13-1. Yep, 13-1.